All right, U substitution is not a factoring method, but it's a very useful tool to help you with factoring. U substitution is also a concept that's used heavily in calculus as well. So learning what U substitution is now, especially if you plan on going on further into calculus, will be really helpful. Um, so let's kind of get into it. So what is it? So U substitution is a technique to simplify an expression by substituting a single variable, usually U, for an expression or function. So what you'll do is you'll let U equal some expression or function, and then you'll go ahead and perform the desired math operations. And then you'll exchange U for the expression or function that you originally assigned to it at the end. Clear as mud, right? Let's look at some examples. So the first example is, let's say we needed to factor x to the fourth minus 4x squared minus 5. Now, none of the factoring methods that you learned, will really let you factor this polynomial, this fourth order polynomial. But this is where U substitution can come into play. So notice that we could write x to the fourth as x squared squared. And we could write minus 4x squared again as minus 4x squared. So I've been able to isolate an x squared in two of the three terms. Now, if I let U equal x squared, that then means everywhere there's an x squared, I can substitute the letter U for it. So here in the first term, when I have an x squared, I can substitute a U for it. And in the second term, where I had an x squared, I can substitute a U for it. Now, this becomes a polynomial that we can factor. This is actually using factoring method 3, right? We couldn't use this factoring method earlier. But now that we've done this U substitution, now this original fourth order polynomial is now a second order that we know how to work with. And so we've got U squared minus 4U minus 5. Using this factoring method 3 that we learned earlier, that will be U minus 5 times U plus 1. Now reverse it. Let x squared equal U, right? It's just the opposite of what we did here. So everywhere there's a U, we're going to put x squared in its place. So everywhere there's a U, we're going to put an x squared in its place. Everywhere there's a U, we're going to put an x squared in its place. So this original fourth order polynomial can be written in this factored form. And we were able to do that using U substitution as a tool. Okay, let's look at the next one here. So we want to factor x minus 2 squared plus 7 times x minus 2 plus 12. So you might be tempted to square this, distribute that 7 to inside the second term and simplify everything. But actually, this is already in a form that we could use U substitution with. So if we let U equals x minus 2, then everywhere there's an x minus 2, we can substitute a U in its place. So here we have an x minus 2, put a U in its place. Here we have an x minus 2, we can substitute a U in its place. Now this is a second order polynomial, U squared plus 7U plus 12, and we know how to factor it, right? We want to look for factors of 12 that add together to get us 7. So that would be 3 and 4. So U squared plus 7U plus 12 is going to be U plus 3 times U plus 4. And now we can just let U since it's already equal to x minus 2, we can now substitute back. Everywhere there was a u, we'll put an x minus 2 in its place. Everywhere there's a u, we'll put an x minus 2 in its place. And now when you simplify inside this grouping symbol, we get x plus 1. And when we simplify what's inside this pair of grouping symbols, we get x plus 2. So x plus 1 times x plus 2 is the equivalent factored form of this original expression up above. And we're able to do that using U substitution. Okay, let's look at one more example. This is using trig functions. So what we've got is we've got cosine squared theta plus 8 cosine theta plus 15. So we can let u be equal to cosine theta. So everywhere there's a cosine theta, we'll put a u in its place. So here we've got cosine squared theta, that's equal to u squared. We have 8 cosine theta, so we can replace cosine theta with a u. Now we have a polynomial we know how to work with, u squared plus 8u plus 15. So factors of 15 that add together to give us 8. That's going to be 3 and 5. So u squared plus 8u plus 15 can be written as u plus 3 times u plus 5. And then we substitute back. Everywhere that we find a u, we put cosine theta in its place. So we have a u, we'll put cosine theta in its place. Here we have a u, we'll put a cosine theta in its place. And this is now the factored form of this original equation. And it's like at this point, you don't even know what a cosine theta is yet. But without even really knowing what a cosine theta is, you can still factor it, okay, using U substitution. All right, so that in a nutshell is U substitution. You will see that here in pre-calculus, and you'll see this a lot in calculus and a lot of other math classes, upper division math classes. Okay, let me know if you have any questions.